Okay, so we talked yesterday about the first part of section 7.4. So this is section 7.4, day 2. And one of the things that we talked about yesterday was graphing logarithmic functions. Graphing things like y is equal to log base 3 of x plus 2. Now remember, guys, we talked about the fact that the easiest way really to graph these logarithmic functions is to change them into exponential functions. And then they work basically the same way as the exponential functions, but the y and the x aspects switch. So instead of a horizontal y equals asymptote, we end up with a vertical x equals asymptote. And instead of plugging numbers in for x, we plug numbers in for y. Okay? Remember, I mentioned to you that in order to unravel one of these logarithms, the log must be by itself. So if there were no parentheses on this, what would we have to do first? Subtract 2 to move it over. But because there are parentheses on this, we don't need to subtract the 2 because the log is already by itself, because the 2 is part of the log. So the first thing we're going to do is we're going to unravel this, and we get 3 raised to the y power equals x plus 2. And then what do? Now we subtract the 2. Now that we broke it out of the parentheses, we get x by itself, and so we end up with, I'm going to reverse the way it's written, x equals 3 to the y minus 2. So this is what we're actually going to graph. So now, we make our t-chart. What is our vertical asymptote going to be? But negative 2 is a number, not an asymptote. X equals, right? It's x equals negative 2. Without the negative 2, it would have been x equals what? 0. So we're going to put that on our graph first. X equals negative 2 is the vertical asymptote. That's going to go right there. And what should I plug in as my center value for y? 0, because that's what makes the exponent 0. So we plug in for y, 0, 1, 2, negative 1, negative 2. If I plug in 2, I get 9 minus 2 is 7. If I plug in 1, I get 3 minus 2 is 1. If I plug in 0, I get 1 minus 2 is negative 1. If I plug in negative 1, I get 1/3 minus 2, okay, which is going to give us negative 1 and 2/3, or negative 1.7. Again, feel free to punch that into your calculator if you'd like. If I plug in negative 2, I get 1 over 9 minus 2. And just to show you, if we did 1 over 9 minus 2, 1 divided by 9 minus 2 gives us negative 1.9. Everybody okay with that? Don't forget to write the values you're plugging in on the correct side, the y side in this case. So 7, 2, 1, 1, negative 1, 0, negative 1.7, negative 1, negative 1.9, negative 2. Do you guys see the picture there? There's our graph. Before we do domain and range, are there any questions about the graphing part? Okay, what's the domain going to be here? What's happening with the x coordinates? It's always to the right of negative 2. So x is always greater than negative 2. What about the y coordinates? Down forever, up forever, so it's all real numbers. There you go. So that's just a refresher of what we talked about yesterday, on yesterday's lesson. And you'll be doing, you didn't do any graphs last night, you're going to be doing the graphing tonight. Okay, questions about that? Okay, there are two other things I want to touch on. One of them is our special types of logarithms, which I referred to yesterday, but we didn't actually go over them yet. There are two special kinds of logarithms, and those are called the common logarithm and the natural logarithm. The common logarithm is log base 10 of whatever. Base 10, our entire number system is a decimal system. It's based on the number 10. Right, if you guys think about the number, 137.24, this is the ones place, which is 10 to the 0 power. This is the tens place, 10 to the first power. This is the hundreds place, 10 squared. This is the 1/10th place, 10 to the negative 1. This is the 1/100th place, 10 to the negative 2. It's a base 10 system. Okay, our positional notation system is all powers of 10. So because that's a common experience in everyday life, everything we do is basically base 10, unless we're working with computers and things like that. The common logarithm gets its name from the fact that it's common to our everyday experiences. It's our common numbering system, log base 10. Because we use it so often, mathematicians got together and said, well, let's make it so that by default, the base on a logarithm is 10, unless you write something else in. And so instead of having to write log base 10 of x, we can just write log of x. The base 10 is implied. That is the only base that can be invisible on an log logarithm. Okay? Any other base has to be written in. And you can write the 10 in, you just don't have to. So if you see a log with no base, it means it's base 10. Any questions about that? The other one is a natural logarithm, and we talked about the fact that the number e, when we learned about it, is useful for modeling things that change on a continual basis in the real world, things in nature, like populations of ducks in a pond. Okay, so log base e of x is our natural logarithm. And because we use this so often as well, mathematicians wanted us to not have to write base e in all the time. The problem is, if I just take the e off of that, what does that tell us our base is? 10. So we can't just erase the e and have everybody know what it is. So to let everybody know that it's base e without us having to write the e, we change the name. Instead of calling it log, we call it ln for natural logarithm. So ln only has one base. It's base e. And there is no difference between the way an log and the way an ln log work. They're both just regular logs, but ln means base e without us having to write it in. Does everybody get that? So those are the two that we're allowed to have no base written in on. If we see log with no base, it's base 10. If we see ln with no base, it's base e. Feel free to write the base in if that helps you. There's nothing wrong with writing it in. Just understand that it's typically not going to be written in for you. So those are our two logarithms. And those are the two log buttons that most of us have on our calculators. If you look at your calculator, you will see typically an log button and an ln button. Now, if you have an log button but no ln button, then when you hit log, what it does is it pops up a menu for you. And that menu will have ln and log on it, log base 10 and log base e on it, are common in our natural logs. So then you can just scroll over and get the one you want, and then you can punch in the number that you need. Okay? Questions about that? Now the problem is, what happens if we're trying to punch something into our calculator that does not have one of those two bases on it? What happens if we're trying to do log base 2 of 7 and we want it on the calculator? Well, most of us don't have a log base x button on our calculator where we get to enter the base. So what you have to do is you have to use what is called the change of base formula. And the change of base formula says that if you have some logarithm with some base b of some number a, and you want to change that to a different base, you can change it to any base you want by making this into a fraction. So let's say we're going to call our new base c. This is going to become log base c of something over log base c of something else. So base c is our new base that we're changing it to. What goes on the top? Our a. What goes on the bottom? Our old base, the b. So if I have log base 2 of 7 and I want to change it into log base 10, I make it log base 10 over log base 10. What am I going to take log base 10 of on the top? 7. What am I going to take log base 10 of on the bottom? 2. So it's going to be log 7 over log 2. That's how you change the base. And it's not just for changing to base 10. You can change to any base this way. Which means if I wanted to, couldn't I change this to ln, base e? What would it be if I wanted to change it to base e? ln of what? Over 2. ln of 7 is not the same number as log base 10 of 7. ln of 2 is not the same number as log base 10 of 2. But watch what happens, guys. If I do log 7 divided by log 2, I get that answer. If I do ln of 7 divided by ln of 2, I don't get approximately the same answer. I get exactly the same answer. Okay, so you can use either one of those when you're trying to punch it into your calculator. Questions about that? So that's the change of base formula. So if I want, I could change log base 2 of 7 into log base 13. What would it be? Log base 13 of what? Over log base 13 of 2. Okay, questions about that? You can use change of base formula for any base. Okay, the last thing I want to talk to you guys about is I want to start to talk to you about a couple of the properties of logarithms. And so there are 5 properties of logarithms. We have 2 minor ones, 3 major ones. We're going to talk about the 2 minor ones only today. Major ones we'll do on Monday. The 2 minor properties, property number 1 says that if you have a logarithm with some base, base b, of some number p, and that p is raised to some power n. I'm sorry, guys, excuse me. Let me write this the right way. Log base b of b to some power p. Excuse me. Sorry about that. Getting ahead of myself. So log base b of b to the p. Notice that this base matches this base. When those two match, it turns out that the answer is just whatever this power is. So for example, if I have log base 3 of 3 to the 7th power, the answer is just what? 7. Why is that? Well, let's think about evaluating logarithms. How do I evaluate this? 3 raised to what power equals 3 to the 7th power? Doesn't that answer have to be 7? Right? You can't have 3 to the 8th equals 3 to the 7th. 3 to the 7th equals 3 to the 7th. So does that make sense, guys, that that's the only answer it could possibly be? These are what I refer to as, and this is my name for them, the 2 minor ones are what I call duh properties. You look at it and you go, duh, I know the answer. So these are duh properties. So what would log base 27,495 of 27,495 to the x squared minus 2x plus 1 power equal? X squared minus 2x plus 1. Duh. So that's our first duh property. Everybody got that? Now, sometimes you have to do a little bit of work. It's not quite as duh. And let me give you an example. But it's not hard. What happens if you have log base 3 of 81 to the x power? And you want to know what that's equal to. Log base 3 of 81 to the x power, so 3 to some power equals 81 to the x. 3 raised to some power is equal to 81 to the x power. Notice, guys, that 3 and 81 share a base. Can't we write 81 as 3 to a power? 81 is 3 to what power? 4. So this is really 3 to the 4th power raised to the x power, which becomes what? What happens when you raise something to a power and then the whole thing to another power? What do you do with these? Multiply 3 to the 4x. So do you guys see that log base 3 of 81 is really log base 3 of 3 to the 4x power? Do you see that? I just changed the 81 to the x into 3 to the 4x. What must this thing now be equal to? 4x. Everybody see how that works? So you don't have to actually curly Q it and write this step. You just have to stop and think about, okay, can I rewrite this 81 to a power using the base of our logarithm? And the answer on this one is yes. So sometimes you have to do that kind of thing. Questions about that? So that's one of our dub properties. Randy?
There's 2 bases in there?
Yes, because your logarithm has a base, and remember that when you take something raised to a power, this guy is called a base also. This is a base, and this is the exponent. So this is the base of the logarithm, and this is the and then this is the base of the number that's being raised to the exponent. So they're 2 different kinds of bases, but they're both called bases. Okay, the other dub property, and it's not quite as obvious why it's a dub property, but it is a dub property. Looks like this. If I have some number p, and some number b, and I raise it to a power, and that power is a logarithm. So b raised to the power log base b of p. Notice that this number base matches this logarithm base. If those match, guess what the answer is? Not log p, just plain old p. So if I have 10, actually let's do this a little bit nicer. 10 raised to the log base 10. Now do I really need to write the base in there? No, but I will this time. Log base 10 of 5x. Since that matches that, what is this answer going to be? 5x. So that's our other dub property. Questions about that? Okay. All right, guys, that's it for the new material. Everything else we've already gone over, so let me give you the homework assignment.